Can you hear it? Okay. We are on the home stretch. Yay. And we have Seth. So this is exciting. Seth was just telling me that cables are like the redheaded stepchildren of electronics. And he's like, maybe 3 people will show up. So I think he's excited you all showed up. So
yeah, this is an incredible turnout for cables. Either everyone's here to come.
He also said he's starting a new support group, CA, Cable Makers Anonymous. So to tell you a little bit about Seth, he is an electrical engineer with the BSEE from UCLA in biomedical and an MSEE from USC with a focus in robotics, giving him a chance to work on cable designs. That's how it's a gateway drug. For a wide range of applications. His challenging career in industrial machinery for the plastics industry, flow sensors or chemical cabinets, O2, am I reading this right? Concentration monitoring system dispensers for the electronics industry, 3 and 2-axis stabilized platforms for maritime and even California's power grid at PG&E has led him to become a one-stop shop for mechanical, electrical, and electrical system design and everything else we can think of, including cable. So welcome, Seth Siegel.
Thank you very much. All right, just the first thing, when I was preparing for this speech, I started watching an episode of Narco as I thought about doing anything else, and this seemed poignant. This presentation was inspired by true events. Some of the characters, names, and businesses, incidences, and locations and events have been fictionalized for dramatization purposes. Any similarities to the names, characters, or stories of any person is entirely coincidental and unintentional. Okay, you'll start to understand. So why are cables important? I'm not sure anybody knows, because they're the last thing that
Because we haven't learned how to train the electrons yet.
Yes, we haven't learned how to train the electrons. Now, I'm sure everyone who's been to EMC testing knows that you come with some foil tape and maybe some braid or something, but guaranteed you're not changing circuit boards probably at this point. You're just slapping a lot of filters in there and you're doing a lot of adjustments to your cables. Maybe you're moving one a little bit to this side and standing a little bit like this, praying to God that hopefully your thing passes. Cables are super important, but a lot of times what we're doing is we're band-aiding bad designs. Impedance control has become incredibly important. You know, now that we have data rates that are up to 30 gigabits per second over USB 3.0, you know, and Thunderbolt, I mean, this is serious, you know. We had a lot of cables that were struggling, and it wasn't because the cable's breaking, it's just because that tight weave inside of a USB 3.0 cable is changing the impedance such that you're no longer passing 30 gigabits, or you know, not even 5 gigabits per second is still not going to be getting passed by. And all of our modern robotic systems are just a ton of circuit boards all over a device, right? You have 3-axis stabilized systems that are going to have, you know, 6-axis accelerometers, and all of your stuff is interconnected all over the place. And they're crazy important, but they're crazy neglected as well, right? So that's the next thing I'll say is that who's responsible for doing cable design? Is it the mechanical engineer? Or whoops, that's not the, is the mechanical engineer? Because there seem to be a lot of mechanical parts involved. Is it the electrical engineer? Because it seems as though they pass electrons at some point. And then is it anybody other than you? That's probably the right answer, right? You will have anybody do your cable except for you, right? I mean, the new guy that's there, that's all him. He's gonna do my cables for me, right? Not it. All right, my background, I was at UCLA during the dot-com bubble growing. I was at Cal one summer, and the guy told me, the best thing you can do is electrical engineering. We need so many of them. I used to eat pizza every single day for free at UCLA because of all those on-campus interviews. A year later, I was starving because there was no more pizza left and everyone was gone, except for maybe I remember one company called Google that no one knew who the hell they were, and no one really attended their information session. I actually did, this was funny that they brought this up yesterday because Society of Automotive Engineering was a group that I worked on at UCLA. I did nothing to do with electrical engineering for them. I machined parts in the machine room. This was the story of my life. People were determined for me not to be doing electrical engineering. All right, first company I worked for, I actually got a job as an engineer. Most of the guys that graduated, and I think there were 2 girls, graduated and they did something other than engineering. I think it was grad school or something that actually makes money. So first company I worked for was a plastic manufacturing company, and I thought this was so beneath me because I went to UCLA and why am I blowing plastic bags up? But I learned a ton of stuff. And I thought some of the funny takeaways from the job were that our chief engineer used not AutoCAD, not SolidWorks, but he did his drawing in Paint, which is a very sophisticated CAD tool if you guys are not familiar with it. It's actually embedded in every single distribution of the Microsoft program. All right, so yes, I felt like it had nothing to do with electrical engineering, but that wasn't really the truth. I learned a lot about PID systems from this, and I really got exposure to all kinds of things that you don't learn in an electrical engineering curriculum, like how to do anything in the real world. All right, my next job was like a real electrical engineering job, so I thought we had like all of like 20 engineers, so that was mind-blowing, and people still used Paint. No, actually, I think my boss at this job was doing most of his electrical engineering work in Word, which actually is, to me, a step below Paint. In any case, this job was a lot of cables. We were doing all our cables in-house, and then eventually we outsourced all the cables. So I went through that process of working a lot with your, doing all of it right there and then shipping all that documentation out to other people. And that's a good learning because you can't go onto the floor and explain something verbally. All this tribal knowledge needs to be incorporated in your drawings, and that's probably the main takeaway from what I had from this experience. All of our cabling was done in AutoCAD, which I still think is an awesome tool for doing cables. If you go to do cables, you're doing a lot of, well, now it's a lot of step files and everything, but if you go to any of your cable vendors, they have tons of 2D drawings that you can import straight into AutoCAD. You can make pretty fancy looking 2D drawings. And although there's not a bill of materials that correlates, I think we all figure it out and we end up getting pretty close. All right, so the last thing I've been doing for the last 2 years, I took over a Altium employee's job over in Carlsbad, and we were making these, I don't know how many axes there are, maybe like 7 axes or something. They're always adding another axis. But in any case, this was a new thing. They're doing all of their cables in Altium, which I don't know, how many people, raise your hand if you're doing cables in Altium. There's a guy. Now this is pretty awesome, and I want to definitely hear from the 3 of you and see what your experience has been with doing cables in Altium. And I'll show you that, well, this is another thing too, is that I was originally hired to this company in order to evaluate SolidWorks Electrical. Has anyone had experience with that program? What's your positive, negative? How do you feel about SolidWorks Electrical? All right, SolidWorks. All right. So I don't really know what that means because I worked closely with SolidWorks, and it was an acquisition, I believe, from a French company, and whether or not that program was exactly tailored to what I bet most of these guys do in here is maybe not clear. So I'm going to guess that most of you aren't doing a lot of DIN rail stuff that involves tons of labeling. You're talking about PC boards that are usually DB9 to DB9 or some permutation of that. That's what we're all doing, right? So we're doing a lot of ribbon cables, we're doing a lot of coaxial cables, and as much as we want to neglect this stuff, it ends up being the thing that's the reason the prototype's not working, right? It's a reason a lot of boards blow up, Connecting power to ground is not good for your system. And as much as your boss wants you to protect for that, okay, I got to ship a board at some point, right? Overall, we decided not to go with SolidWorks Electrical. It was a really young product two years ago, and I don't know if it's made any advances towards something that was usable, but it was extremely complicated. And cabling, I think in the end, what we really want is something easy to use. No one wanted to do it in the first place, and definitely no one wanted to spend way more time than they had to on it. So I think that's why AutoCAD ends up being something that we love. It's missing a lot of things. There's also, we'll go through this. So here's the options that I went through, and I researched a lot of things. Now, these aren't necessarily things I use, but if anybody has experience with it, we'll chime in and we'll get your feedback on these different tools. So SolidWorks Electrical, we talked about this a lot. My experience was that it was complicated. I'm interested to hear from you of whether it's developing or if it's maturing as a product.
Different needs, different spaces. So for what you use, again, I'm on the PCB side. My background is in PCB design as well. When I first looked at electrical, it's not your PCB design tool. So it's more toward paneling, big displays, not board-to-board.
Exactly.
They have a bunch of manufacture, a lot of capabilities. As you mentioned, if you're looking for, board-to-board, it's overwhelming.
Right. Yeah, and basically, I couldn't get anything to compile. I spent lots and lots of time, and we can all know how frustrating it is when you finish a board and the thing isn't going to compile. This isn't a tool that makes you feel better about your life. No, now don't worry. First, I'm going to smack SolidWorks down, and then I'm going to build them back up. Because I've been a SolidWorks user for years, and I love SolidWorks. So every single CAD system crashes. All of them do. We saw Altium do it a few times yesterday, right? Now, this is another cabling software that's being pitched. It looks as though it's tailored closer to what we do. The drawbacks that I heard about it from the web were that it's crazy expensive. I actually tried to contact these guys to get a quote. They didn't even get back to me, so I'm not 100% sure. I actually learned about E3. It's E3.series, I believe. It's a German company. I don't know. Is anyone here familiar with it? Wow. Okay, so this probably doesn't have that broad of a user base. That's from my guess here. Now, Visio. Has anyone done their cabling in Visio? All right, I got one Visio guy. Right. Visio has advantages. because we know how to use Word and we know how to use PowerPoint. And so basically, I think that translates into Visio. And I don't mind Visio, actually. It's a lot better than doing your cabling in Word. And
At least the connections stay connected.
at least the connections stay connected. That's a huge bonus, right? I've done tons of system level diagrams. They have OneNote now, which actually OneNote and Visio have similarities to them. What I don't like is that I don't want to have 40 different tools that are being created for all types of stuff. And in the end, I'm drawing a bunch of symbols. Drawing symbols in Visio is a pain in the butt. It's not like AutoCAD where it's just straight up, DXF in there and we're good, right? I mean, it just seems more complicated than it needed to be. I don't really care about little pictures that float around and putting one little net that, to me that's not important really. I see that theme in a lot of things, and I guess maybe it's important to somebody else, but to me I'd rather just have a visual representation of a cable that I can give to a manufacturer and get produced well, and we'll talk about that. AutoCAD electrical, show of hands. All right, I've evaluated this product, but I've never purchased it, and no one in this room, so we'll just. Autodesk is, I don't know their sales. I think this is, again, something that's really tailored more to people who are doing big cabinet systems, when you have a lot of labeling that you want to do, a lot of DIN rail stuff. And then there's Altium, schematic capture tool, which I've been using for the last 2 years to pump out a lot of cables. And you can actually start to really pump cables out with this thing. They still take about 2 days, but at least you had a bill of material that you could send to your vendor, and it was driven by parts that were in your database. And I'm pretty sure that everybody should be building all this stuff into their database anyway, because you're building a bunch of boards and your I/O connections, and at least you have a net list, right? So there's a lot of advantages to doing your cabling in Altium schematic capture tool, right? Okay, so no, heck no. I mean, these, all right, so these are just 2D from the manufacturer, right? You're gonna create parts, and then these are all just subparts in there, right? So this is a projection that you just get off of the web for that D sub. And this is the main issue with doing stuff in Altium this way, is that every single thing in here needs to be another part in your library. Everything, because you need them all to show up in the bill of materials. And the D sub starts always being the thing that you come back to, because D subs are super complicated, right? 45,000 versions of this back shell exists. Does it come with the hardware? Does it not come with the hardware? Who knows? Who knows which one I'm buying? Is it stainless steel? Is it this? I mean, there's so many versions of D sub. It's crazy. And that becomes right, yeah, let's go mil spec and really see if we ever get a cable that someone can reproduce. Like WW123, I mean, I can't read this in here, but yeah, I mean, yeah, we've all done a lot of cables, but this is what you can easily, and if you guys go into this, you can watch this video, and this is actually from Altium, and it's just kind of like a bunch of papers that explain exactly how you would build a library so that you could create this exact drawing here. So these are parts, right? And then this is all drawing in Altium schematic, right? So this is just some kind of, spline line. And then all of these callouts are actually parts. They're subparts in your part, right? So but it's very tedious, right? The numbers are always falling outside because of some way someone created the libraries and stuff. So there's so much massaging. That's how you end up into a 2-day. But you did end up with a BOM that represented, and it came out of your library. And that, to me, is super valuable. And I think it's something that makes this a real option. It's time consuming, it's error prone, but maybe it's less error prone than using just AutoCAD and hoping that your bill of materials and all of the BOM callouts are working together.
Yeah, something that comes in real handy if you're doing something like that connector.
All right.
You're trying to make a harness like this and you have a connector like that, something that comes in real handy if they don't just have a, something that's really easy to import as an image. When you're creating the part, you can import a DXF. And so almost all connectors will all have a DXF that you can download. The only problem you have to watch out for is the scaling.
Yeah.
So make sure it's not absolutely gigantic when you put it in.
All of this stuff, no way we drew this. I mean, these are EEs doing this. They're not mechanical engineers that are super good at 2D projections. So all of these are DXFs that you can get off manufacturers' websites. But each part is a subpart, right? So this, first you're going to place, and if this all has to be layered up the right way. So I brought this to the front because this is the back shell. If you look inside there, there's another thing that is the full-on D-sub in there with like whatever, it's solder cups or maybe this is pins. And then the pins have to exist in there, right? And then if this hardware, so all of these BOM callouts are a separate part inside of your Altium library.
So are these parts linked to your schematic?
You want to take the, sorry.
Are these parts, so
Every-
are
yeah.
these parts linked to your schematic? So if you change something in your schematic, would it change in this drawing that you're showing right there?
Right. Yeah. So I mean, yeah, these are all subparts of the same part, right? So you place this part first, maybe, and then here's your bubble call out that just has your number, and yeah, they're all part of that part in your library. So you're building up this library with everything. Sorry. Throw this. Go ahead.
I think the question was, does that schematic or that
Yeah, this is on a
wire table correlate back to the connections in the schematics down to the board? Is that, or?
Well, no, the schematic.
Oh, okay.
There's all those pins in there, and you're showing a harness. You're showing like 4 connectors in that,
Right.
5 connectors in that view. Those 5 connectors are the 5 connectors that you're showing up here.
This is on page 2. So this is just right here is showing the schematic. And so you would have this entire harness and you would have that schematic on there. And this is what your cable house is going to use in order to match this up. This can either be a physical schematic this way. Sometimes people are doing it in an Excel BOM or something. But when you start, so look, here's a complicated thing, right? So now you have 2 wires that are being spliced off and sent to 2 different D-subs within your cable. That's kind of complicated.
Do you have a wireless cable on the schematic, or is your assembly house, cable house following the Altium schematic?
Altium schematic, and then sometimes also we're putting another spreadsheet embedded within there. So there could be a pin-to-pin list in there, and then it kind of depends on the complexity. I mean, if it was a straight-through cable, then usually it's just look at the physical net list on here and then use that. But at least you can export this net list and stuff, and you could do a lot of stuff with that, right? All right, I think you had a question.
With that, with doing a cut list like that, is there a way to attach metadata to the traces that would tell them what, like wire thickness, color, like things like that?
Oh, absolutely.
And auto-generate a cut list that would be updated when those change.
No, it's the wire is a part. All of that is a part. So there has to be a part in here for the cable or the wire, whatever it is. There's a part in there and then an associated length. We used to do all the wires as just NA, but at some point when at some point they wanted actual lengths when they were moving into a new ERP system. So I guess SAP wouldn't allow as required. So
Is
then
there one of these that you could make available? Just a generic harness that was designed in Altium that we could download on our own time and pick apart and see how it works?
Absolutely. I can create something simple. All right, my sports skills are limited. That's why I went into electrical engineering. All right. I was at USC and I was not on the football team. Right, yeah, no, I can definitely make a cable for you and make it available. I think more than anything, you can go to these two links right here and get a step-by-step explanation of how to create your libraries. I mean, they're telling you everything to do here. Now, they don't actually, I asked Dan Goddard if people are using this, and he said no. The only person who's doing it in the world is one company in Carlsbad. But I've talked to other people that are actually drawing in Altium. I mean, Altium is a powerful drawing tool, you know. I mean, to me, it's definitely a step above Paint, and it's a step above a few different other programs that are out there. Now let's just talk about cables in general. You know, what do you need to deliver to your manufacturer in order to get a good cable? Time here, anywhere. All right, so definitely we want a good BOM. We want a schematic or some sort of net list, whether that's from Excel or if it's a graphical representation like we were showing there. We want annotated drawings, you know, we want to be able to have all these notes. We want to have reusable notes. You know, a lot of this stuff, even when we're doing it in AutoCAD, is just we're taking all these standard notes that we've had, our experience with different cables. We're reusing all of that stuff as we move along. So the notes are important, and this is what's key to getting back what you wanted. You know, documentation is huge. Who are your customers when you're making cables? That's an important focus on it. Now, to me, it doesn't matter whether you're using a contract manufacturer or if you have people on your floor that are building cables for you, or if you're building it yourself. You want to be able to move this cable from one person to another and no one calls you. Less calls is better, right? We all know it doesn't even matter where you're shipping something to your contract manufacturer to build a new PC board. The less calls you get is a reflection on how much upfront engineering time you spent on your documentation, right? From my experience, that's what I think. You know, less email support. If you're not getting any emails back and you got a cable back that your inspection team was able to verify, they knew how to verify it. How many times do people get a call from their inspection team and they're like, I got this cable here, what do I do with it? Like, you know, do I put this on cable eye? Do I get my own meter out and start testing connections? They could come up with some kind of scenario that they're working on your cable for the next week and you're like, okay, first article, quit it. We're ready to ship this thing. So, you know, and procurement, all those parts that are within your cable, it's important that they can second source, third source, fourth source these things without giving you a call as well. So a lot of times engineers put a ton of information that doesn't matter on there. I would avoid putting a bunch of information that you don't care about, and I would stick to information that you do care about. And if you didn't care about, you could even say, I don't care what color it is, green, pink, yellow, whatever. Send me that. If it's fine, if it meets my technical requirements, is that the bend radius is this, it's within this spec, great, I'll take it. All right, let's take a look at one of these cables right here. So this is a pretty good cable schematic, right? We have a good wiring diagram in here. They actually have some packaging information, so how do you want it shipped to your company? That's important for when it's going to go into your You know, when it's going to go into your inventory control, these guys probably have something that they want in terms of it being in a plastic bag or a box or in a piece of foam. Do you want 40 of them in a bag? And actually, I don't really like this, putting it directly like this on here. I think it should probably be a note call out on here and then have another spec that leads to that, because this is something that somebody comes into your company every 15 minutes and decides they want to change, right? Oh, the new guy on the block came here and he did it this way at his company, so he's going to change it. And I don't think as electrical engineers we care much about how it's packaged there. But this is something you're going to get a phone call about, and so it's something to stick with. And there's a lot of good stuff on here, right? Now, I don't really like putting bills of material on a drawing as well, because this is another thing that we want to change every 5 minutes. You know, companies are always changing their part number. Maybe it's the exact same cable and they just changed the part number. I don't know. So those are probably things that you want in your ERP system. But overall, I think it's a good cable. There's a good tolerance on here. You know, this is a 1800 millimeter cable and just plus or minus 20. Someone can go there, take this. You see exactly where to measure it from. I'm pretty sure that, you know, they could put this on a cable eye and be able to test it out. I don't see any. Oh yeah, there's even a resistance on here. This resistance just says 5. Is that less than 5? I'm going to guess that it's less than 5 ohms. It's exactly 5. So that might be an issue. I don't know if you could nail 5. Actually, I'm going to guess that 5 is pretty bad. Wait, I don't know. 5 sounds. Yeah, 5. I don't know. 6-foot cable, 5. Wow. I feel like there's a lot of power being wasted in this cable. All right, now this is a really hard cable to get right. Now, how many different ways can I screw this cable up? Who's had this cable come and it doesn't, and it blows up your board? Right? You would think that, yeah, you would think this is the easiest thing in the world, but you know, do you want it to come from this way or that way? I mean, these cables have ruined my life for at least a week or a week in time. But this is still another, you know, look, 100% electrically tested. You know, okay, at least they're going to test something, so that's good. They're going to, you know, I think, yeah, I mean, I think it shows that, I think it's a pretty good drawing. I think from this, you know, you see that yeah, you see this is on the outside here, this on the outside here. So this is what I would expect from a ribbon cable drawing. Some people would say, oh, how come you don't just give them a BOM and a net list, or a BOM and an Excel spreadsheet telling them how to pin it out? Well, that's not going to work with one of these cables for sure. All right, now here's my new proposal. So I saw Draftsman come up in July from one of these live demonstrations, and the idea with doing the cables in Altium was that everything was done in the schematic portion of Altium. But really, the way Altium is designed is that your logical diagram is supposed to be in there and all of your metadata, right? And then you're supposed to move that down into your physical board, and that's where you're actually doing 3D parts. That's where you're actually putting traces. That's where all of those 3D parts go in. Now, SolidWorks Electrical can export step files, right? So you can use SolidWorks Electrical to do all of this routing, which this tool is amazing. This tool works great. This is something that SolidWorks did themselves, and I believe SolidWorks did themselves, and it works amazing. You flatten this out and you have a pretty good, I mean, maybe you might have to tweak this, but you could definitely see someone making a pegboard from this, right? This is something I could work with. And a lot of people, what they're doing is they're just having a mechanical engineer run through there with a string, and that, you know, heard someone call it on a string and a prayer. It's a pretty darn good way, actually, of representing the length of a cable. But, you know, unless I actually had a physical design there, I can't actually do that. So, you know, SolidWorks routing, electrical routing, which is different than SolidWorks electrical, which is confusing, is a fantastic product, and it's definitely something you can export a step file, and you can export that step file in all its different pieces into Altium, and you could create in Draftsman a cable design in layout, right? Because we've all been putting 3D parts into our layouts, right? The other day I was talking to somebody at lunch and he said, oh, well, I'm not a 3D guy. I can't do 3D. And I said, well, what are you doing here? Because anybody who can't do 3D can't make a circuit board in 2017. Because these things have interactions to your boxes. Everything has an interaction in a 3D. So we are electromechanical designers as people who do Altium design and people who do electrical engineering. I don't see any way out of it. Unless you're the guy, and even if you're the guy doing silicone, I mean, silicone is a 3D part. So I know vias are 3D as far as I know, but you know, this is basically, I saw a tool that's really good at doing a lot of things that Altium schematic capture is not good at, right? It doesn't like doing annotation. It doesn't like doing notes. All of these things, we force it to do that, but it's not, you know, it's not what it wants to be doing. We got there, but it's not exactly happy. So here's a chance to create your libraries in a different way. And I can use all the same libraries that I was doing in the 2D portion, right? And so here where I end up with my documentation, right? For this is just pulled off of the web as a circuit board. But all these callouts and stuff, these are amazing. And what I would have to be doing for all of these, so this is going to give me a little view of this part. So if this was a cable, for instance, then you could just be looking at that part and showing the exact way that I'm doing the braid, the way that I'm interconnecting that braid with my back shell and stuff. That could be super important. I worked at places where if you did not fold your braid exactly right, it did not pass 60945. That wasn't happening unless every single cable. And when we went to compliance testing, more often than not, it was a broken cable. It had nothing to do with anything else. So this is pretty much what I've been working on developing libraries for, is putting all of those, all of the step files, and most companies, they have DXFs and they have all the step files. So, you know, importing, and probably you wanted all this stuff anyways, because as you build up your electrical box or whatever you're putting your circuit board in, you had to put these models in there already, right? So, I mean, this is basically, I'm seeing as the next logical step in that evolution of creating one stop for systems engineering in Altium. Okay, yeah, so I want to turn it over now to you guys and see what people think about this idea, and then see maybe what they're doing, if they see anything is. Any questions?
So this is something you're proposing in the future. It's not something that Altium does currently.
No, this is something I'm doing right now with Altium, and I'll send you guys some of my design files. Now, so I got stuck with crashing on Monday, and I couldn't. A lot of my stuff wasn't loading up, so I couldn't put the pictures of the ones I have. But I'll send you the cables that I've been able to do. I've finished a few cables that I've done in Altium as layouts, but they're done in here, and I've finagled all the connections. All right. And you can just take the step file and kind of fake it.
If you don't have the luxury of SolidWorks and you have to document the cables without having SolidWorks, what's the next best option in your opinion?
Yeah, all right, so obviously SolidWorks is super expensive, but Sorry.
It's true.
I keep forgetting she's here. No, I mean, I in general think so as electrical engineer, possibly you have no affiliation with SolidWorks whatsoever. Now you can still get all those step files, and they do extrusions in Altium. So I have made extrusions just to do a straight line from one cable to the next, right? Because you're just putting your connectors on the ends, and the rest of it was just drawing lines. So let's go back to what you really. But I haven't figured out anything yet to do some of these more complicated, like that's a spline, and right now I don't. So I don't have answers for some of these things, but I've been able to do straight cables in there, and kind of what I'm leaning towards now is a little bit of a hybrid design, which is that, you know, some things I can do, some things I can't 100% do. And part of my pitch here is that hopefully Altium would look at this and help us out as that take that next logical step, which is to make it so that we can put cables into our systems design, because we want to have a multi-board tool. We want to be able to design everything, and I don't think any of this steps on SolidWorks at all, but maybe it kind of does at some point, because they were talking yesterday about exporting step files from Altium, right? That's a big complaint. How come I can't just, and SolidWorks sells a tool that you can export and import from the Altium tool back into your SolidWorks drawing. And so, unfortunately, that's also another purchased part. I don't know what's the cost on. Yeah, I know, but connector. And that's really the only interface you have to take what you have in Altium, which is, you know, your whole built-up library, and export it into your SolidWorks mechanical assembly. What is the cost range on that? Yeah, you can never get. No one knows. No, I know. It's hard to figure out. Yeah, I mean, everything's hard to figure out the price on. So, you know, that's just part of it. Oh, one more question. I think we have time for one more. Oh, go ahead.
So I was just going to say, we currently do use Altium to make a lot of our harnesses. I think we've made about 10 that we've produced, and you know, a lot of these same things apply. You know, make sure there are plenty of notes, because if something's not clear, they're going to come back and ask. You know, if you don't have that little line that says measure from this exact point on the connector to that exact point on the connector, they're going to say, well, where do we measure? And another thing, we have a schematic library of just connector stuff, and so, you know, part A will be the schematic side here, and then B and C will be the kind of image representation. And so when you place the part, you just place that, place the other two, and then it shows up in your BOM as that connector. And then you can have your electrical side over here, and then your kind of representation on the other part of it. And on our drawings, we'll have all this, you know, our harnesses aren't that complicated, and so we'll usually have the whole harness on just one sheet that has the image representation of what it's going to look like, and then we have the electrical side of where to connect. We also had one project that we were going to try and rush through in 3 months, and the reason we couldn't do it was not because of the firmware, it wasn't because of the board design, it wasn't because of any component on the board, it was because one of the connectors in the terminals had a 16-week lead time. And so if you guys are looking at a electromechanical design like this, I would also recommend that we scrub your BOM, you know, make sure you're not using some end-of-life capacitor or something. Also look at terminals, because just recently I made a cable where we asked for a quote on it, and they said, oh, well, we don't have that applicator to put the terminal on the wire, so here's a 10K NRE. What? You know, so...
All right, I think we're out of time, but I will say, everyone message me, and I will send you both types of files that I have, everything that I have, and you can see exactly how I put libraries together and what you can do with SolidWorks as or Altium, Altium as a cabling tool. Thank you.
Thank you, Seth.